Welcome to the Wonderbox channel. Today, we embark on a captivating journey through history. Prepare to be inspired and amazed as we delve into a pivotal moment in human understanding. In 1687, a quiet revolution began, not on a battlefield but in the pages of a book. This book would change the course of scientific thought and lay the groundwork for modern physics. Enter Sir Isaac Newton, a scholarly yet reclusive professor at Cambridge University. For years, Newton grappled with profound questions about motion and the nature of gravity. His quest for answers would culminate in a singular work that still resonates today. Though legends often depict an apple falling from a tree as the catalyst for his insights, the truth is far richer. It was not merely a falling apple, but a relentless pursuit of knowledge that illuminated Newton's mind. In the heart of Philosophia Naturalis Principia Mathematica, he articulated concepts that had long eluded humanity. He introduced to the world three universal laws of motion. These laws would serve as the cornerstone for understanding the dynamics of both terrestrial and celestial bodies. And let's not forget the law of universal gravitation, a principle that connected the motion of the heavens with earthly phenomena. What was the transformative power of these ideas? Imagine this. The same gravitational force that pulls an apple to the ground also governs the moon's graceful orbit around the Earth. With each stroke of his quill, Newton forged an invincible bridge between the earthly realm and the cosmos above. His meticulous calculations, combined with lucid explanations, laid the foundation for a new discipline: classical mechanics. But who exactly was Isaac Newton? Born in 1643, he was a man of contradictions, a brilliant thinker yet often withdrawn and solitary. Much of his genius took shape during those turbulent years of the English Civil War, when he returned to his hometown of Woolsthorpe, seeking refuge. It was during this period that his mind began to flourish, contemplating the workings of light, color, and motion. As he immersed himself in these studies, his thoughts began to crystallize. However, after years of seeking and scratching out calculations, the decisive moment arrived. Newton meticulously drafted what would become the Principia, secretively working on the manuscript for nearly 20 years. Upon its publication, many considered it a marvel, a divine revelation encapsulated in mathematics. The principles he presented weren't merely theoretical musings. They were truths that could be observed and tested in the physical world. His first law described the inertia of an object, the tendency of matter to resist changes in its state of motion. The second law defined the relationship between force, mass, and acceleration with the famous equation Thas South May. The third law noted the equally opposite reactions produced in every action, establishing a profound interconnectedness within the universe. These laws were not isolated. They constructed the foundation upon which mankind would unravel the intricacies of the cosmos. As readers of the Principia embraced Newton's work, the scientific community began to awaken from centuries of philosophical dogma. In the pages filled with precise calculations and captivating insights, they found a new language, one that spoke to the mechanics of existence itself. Suddenly, humanity was no longer at the mercy of whims of fate or divine intervention. Instead, they could employ reason and experimentation to decipher the laws governing the universe around them. As the world began to comprehend these ideas, they reflected on the implications of gravity itself. Surprisingly, Newton's law of universal gravitation didn't resonate immediately. Initially, many remained skeptical, unsure of how a single force could govern celestial orbits and earthly motions. Yet, with time, experiments validated Newton's ideas. The rigorous work of astronomers and physicists ensured that they could witness his theories unfold before their very eyes. Moreover, the Principia became a powerful text that transcended borders and centuries, an indelible mark on Western thought. Newton's profound impact on the intellectual landscape of Europe was nothing short of revolutionary. Upon securing the respect of both fellow scientists and philosophers, he paved the way for the Age of Enlightenment. Imagine a society once steeped in superstition and conjecture, now inspired to pursue the empirical study of nature. The abilities to ask questions, conduct experiments, and seek evidence ushered in an era characterized by intellectual rigor. It was not merely the discoveries of Isaac Newton, but the method he demonstrated that truly altered the course of human understanding. From this moment forward, scientific inquiry blossomed into a thriving discipline that would enrich culture and technology for generations. His influence reached beyond physics, prompting advancements in fields ranging from chemistry to astronomy to engineering. Those laws of motion, solidified on the pages of his work, would define not just a discipline, but the very framework of how mankind approaches knowledge. And what of the legacy Isaac Newton left behind? It is impossible to measure the magnitude of his impact on the world. He became a symbol of enlightenment, a figure whose intellect resonates through the ages. His work inspired luminaries like Albert Einstein and countless scientists who would follow in his footsteps. Every time we marvel at the moon in its orbit or feel gravity's gentle pull, we witness the echo of Newton's brilliance. But let's not forget the sheer power of curiosity that drove Newton to question the world around him. That same spirit of inquiry lies within all of us. As we navigate the complexities of modern life, we must nurture our desire to explore, to wonder, and to seek knowledge. With every question we pose, we emulate the great minds of history, those who dared to challenge existing paradigms. Perhaps within this dialogue of inquiry, we too can be a part of the continued evolution of thought. As we draw near to a close, we reflect on how complicated the universe is, yet how beautifully interwoven its laws are. Newton's work serves as a reminder that through observation, reasoning, and experimentation, we can untangle the mysteries of existence. So, what lessons can we derive from Newton's Odyssey? In a world filled with distractions, let us channel our focus into our passions. Let us pursue knowledge with the same fervor that fueled Newton even amidst solitude. The brilliance of Principia Mathematica was not limited to its equations, but resided in its invitation to explore the unknown. As you delve deeper into the annals of history, remember that every book contains the potential to change our perspective, and every mind holds the ability to ignite a revolution of thought. If you found this exploration of Isaac Newton's legacy intriguing, we encourage you to take action. Like this video, subscribe to the Wonderbox channel, and join us on future journeys through the realms of wonder and discovery. With that in mind, let's continue to embrace our curiosity, for who knows what revelations await in the pages that have yet to be written. Thank you for joining us on this incredible exploration of the birth of modern science. Until next time, keep questioning, keep exploring, and keep wondering, for the universe holds infinite possibilities.